Okay, this video is to help you learn to do multiple step heat problems. So we will be going through the worksheet, multiple step heat problems. We started this yesterday, but we had a fire drill, so we're gonna pick it up and move from there. Okay, starting with problem 1, it says that you have a 525 gram block of ice at 0 degrees. So we need to figure out where we are on this graph. So you are a solid, and the solid occurs right here. So here's your solid down on this part of the graph, but you're a solid at 0 degrees, which means here's 0 degrees, that's the melting and freezing point of water. So you have to be right here. So we're gonna start right there. And then the problem says that you're gonna heat it until you completely melt the block of ice. Okay, but it doesn't say anything about a temperature change. So we're gonna completely melt this block of ice and end right there. So that's our start and our end. Now you can see that we only cover one section of the graph here. So even though this thing says multiple step heat problems, this problem is only a single step. That's it, one step. So we're gonna use the Q equals M delta H equation for this, because that is the equation we use whenever we're on a flat part of the graph. So Q equals M delta H. In question 1, it tells you that you have 525 grams, and that your delta H in this case is 334 joules per gram. And if you multiply those together, you're gonna get 175,000 joules. Oftentimes you will see that these things get reported in kilojoules because that is a big number. So it's easier for chemists to just move the decimal place 3 spots and call this 175 kilojoules. Okay, so anytime you see a K in front of that J, it just means that they've chopped off 3 numbers and made it a little bit bigger. Okay. Now we're going to go on to question 2. So question 2 is super similar. Question 2 says you have the same 525 gram sample, but this time it is completely liquid, or it's just water, at 0 degrees. So we know that this is our 0 degree plateau here, but now you are completely water. So this part was a solid. Here we're melting, so we're solid and liquid. So we need a spot where we're only liquid, and that occurs right here. Because this whole part, this upward part, is where your liquid is. So if we follow this down, liquid, 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 this is the last place where you are completely liquid and 0 degrees. And it says we're going to heat this thing to 44 degrees. So let's put in our other reference. Boom. That's not a very straight line, but you get the point. Here's 100 degrees, because that's where our water is going to boil. So we must be between 0 and 100, so about halfway. So we're going to end right here. That's where we're our ending point. And again, even though it says multiple step heat problems, we're going to do one step. We are on one part of the graph, this red section here. So that thing then is going to require our red equation, Q equals MC delta T. So Q equals MC delta T. We're still at 525 grams. The problem tells you that your specific heat is 4.18 joules per gram degree C. And then we have to find out the change in our temperature. So we always do our ending temperature minus our beginning. So we're going to take 44 minus 0. So we're going to end at 44, start at 0. And if you multiply all that together, you're going to get 97,000 joules. Again, I've rounded my answer. You won't get that exactly, but we're going to round. We'll talk more about significant figures. We're just going to round to a nice number. Or you could report it as 97 kilojoules, because if we took our decimal place there and moved it 1, 2, 3 places, we'd be left with 97. So that'd be 97 kilojoules. Okay, so now we have the next piece, which says that we're going to take 525 gram block of ice. Starting to sound familiar here, right? So get rid of this. So we've got 525 gram block of ice. So we're here again. It's the only point where we have a solid at 0 degrees. And we are going to heat this thing until it becomes a liquid at 44 degrees, which is here. So we're gonna end right here. So start and end. Well, this time we truly do have a multiple step problem. Okay, we have to go across a flat spot, and then we have to go up a slanted one. So we need to use both equations. We're gonna have to use Q equals MH and Q equals MC delta T, and then we're gonna add our two values together. Now, we've already done this math. Really, question 3 is just question 1 and question 2 put together. And we found out before that this was 175,000 or 175 kilojoules. And we found out that this one was 97 kilojoules. So the total trip from our start to our end is just going to be Q total is equal to 175 plus 97 kilojoules. And that's going to work out to be 272,000 joules or 272 kilojoules, however you want to look at it. So the moral of the story, I suppose, is that whenever you're solving these problems, what you want to do is you want to identify where you are going to start on this graph, okay? Then you are going to figure out how many steps are involved. So in this case, I have one flat part, that's one step. I have one slanted part, that's second step. You're going to solve each one independently, and then you will add up all your answers together. Now the key is, this is going to get weird, you have to make sure that the signs of all your individual pieces are correct. So in this case, we were heating, and heating, whenever you're putting energy in, the values are always going to be positive. Okay, so positive answers. You notice I have a positive 175 and a positive 97. I got a positive 272 kilojoules, right? But if we were to reverse this, if I were to start up here and end down here, the math is exactly the same, but I would have a negative 175 and a negative 97, and I'd get a negative 272 because I'm pulling the heat out. I'm subtracting the heat. Okay, so just be careful about that, because you will notice that sometimes the math will give you a positive number, and you have to override that. You have to say, wait a minute, I'm cooling this thing down. It has to be a negative number, and you have to scribble in the negative, even though your calculator doesn't tell you. Okay, I'm going to make another video with question 4, and you can pick up from there.